In this section, we are going to look at two critical electrical phenomena, the voltage and current, and they are of utmost significance to us in this course and in electrical engineering in general. Voltage and current. These are the two phenomena that we are going to look at. Now, what is important is that both of these phenomena, they are artifacts or they are characteristics of an underlying aspect, which is electric charge. So both voltage and current are artifacts or characteristics of electric charge. Okay, so let's look at their definitions and their physical interpretations. Now, voltage is nothing but it's a measure of separation of charges. You see, in general, positive and negative charges like to stick to each other, they attract each other. But when you want to separate them, you need to do some work. Okay, that creates a potential difference. Voltage is a measure of how much work we have to do in order to separate charges. Now, current, on the other hand, it does not come from the separation of charges, it comes from the flow of charges. Okay, so voltage is an artifact of the separation of charge, while current is flow of charge. Okay, so let's define those terms. Voltage, therefore, is defined as the amount of work we do in separating charges. Okay, W is the work and Q is the charge. If you express it in the differential form, dW over dQ is defined as voltage. Okay, and you'll see me using these three lines to represent a definition. Okay, this means a definition. Now you can also define current. Okay, now current is I is defined as rate of flow of charge. Okay, so there is a time quantity T in the denominator and there's charge in coulombs in the numerator, and if you express it in the derivative form, it is dq over dt. So this is again a definition. Now let's define these terms really quickly. I is current in amperes. And V is potential or voltage in volts. Okay, and then W is the work done, work or energy in joules. Then Q is the charge in coulombs. Now, what I have not mentioned is that both potential, okay, and voltage, they are vector quantity. They have polarity sign associated with them. So something very, very important we should not forget is sign or polarity is important. And that is important for both voltage and current. And we are going to look at that in the next section when we visit the passive sign convention. That is where I'm going to give you specific directions on how to assign a polarity for voltage and current. Okay. Now, the other thing that I want to show you is these voltage and current quantities. You have seen them already. Of course, you have seen them in your prerequisite courses, in your high school courses. But in this chapter, we have seen electrical current. It's a fundamental quantity, or it's a defined quantity, defined unit. Then there is electrical potential, right, which are used interchangeably as voltage, electrical potential. They all mean the same thing, and its unit is in volts. So you have seen these quantities before, and then here are the definitions. When we go to problems, we are going to use these definitions. The derivative of work with respect to charge, that gives us the voltage, and on the other hand, the derivative of charge with respect to time, that gives us current. We are going to use these definitions in the problems, and if we have to change them into integral form, we will do them and then apply these definitions.